Good morning. Can you guys hear me? I guess it's not really good morning. It's kind of late. Can you guys hear me just fine? I don't know how many people will join if we don't make an announcement. I kind of want to make an announcement. Okay. I'm just going to post on Discord real quick and get some more people in here. Alright, GM, everyone. I'm just gonna wait a few more minutes while people join. Let's play some better music, shall we? Wow, there's so much sad and angry music. Just gonna do like some hip hop. No angry, no happy hip hop. I'm doing good, man. How are you? I'm not gonna play Hindi music, bro. Not here. We'll start in like 2 minutes or so. We're starting from scratch. You need to have a decent handle on JavaScript. Like, you need to be able to understand what's going on. like we have some links in our freshman track to help you get started. We curated some good free resources you can use to get started. And our moderators here run like 2-hour sessions every single day, other than Sunday, where they help beginners learn JavaScript. I would advise that, like, if you're absolutely new, I don't know how much of this stream would make complete sense, because this is sort of the sophomore track, so this comes after freshman. But maybe like stick around, see if you like it. But like, you probably want to start from the freshman track first, if you get lost. But that's okay. It's a marathon, not a race. Yeah, I think like this is a sophomore stream, so I feel like we will have less of an audience here joining us live. Just because like there's not as many people who are on to sophomore yet. But let's get started. Actually, just gonna wait for one more person to join. Somebody messaged me. Okay. Yash, do you know if the other mods are joining? Prasanna, so difference between storage and memory. I'll cover that once we get started. I think I covered a little bit of that in one of the freshman videos, but if you weren't there, I'll cover that again when we start, because I know like a lot of people are confused about that, so it should be helpful. Cool. Okay, let's start, guys. I'm gonna pause this music, and I'm gonna close Discord so I don't get pinged. And all right, let's go. Cool. So, hey everyone, I'm Hardik. You've probably seen me around the LW3 Discord if you're here. I'm one of the co-founders of LearnWeb3, and today we are going to be doing Sophomore Track Advanced Solidity. So a lot of people have been requesting this. Usually we only do videos for the programming levels. So for freshmen, we only did videos for the 3 programming levels that exist there. But a lot of people were asking us to do Advanced Solidity level in Sophomore before we move on to the programming stuff. So that's what this is. At any point, if you want to ask me questions, just post questions in the chat, and I will be looking at them every now and then. And yeah, so let's get started. So I'm gonna do this level on Remix, so I can show it to you. We don't need to set up hard hat for this, but I'll just do it on Remix, so we can program as we go. I apologize if my internet is a little bad today, but hopefully it should be fine. So let me zoom in a little bit. So all right. So I'm just gonna get started. I'm gonna make a file, advanced solidity.sol, and we're just gonna do the things we already know we should do. We're gonna add a license. This is, I guess, optional, but just so we don't get any weird warnings. And we're gonna be using Solidity version 8.4, let's say. And let's create a simple contract. So contract advanced solidity, and we will be doing everything we want to do here. I'm going to open up the track for reference. So the things we want to cover, let's make a list of everything we want to cover today. So first, mappings. Then we will take a look at enums. We will take a look at structs. We'll take a look at view and pure functions. We will take a look at modifiers. So the reason we want to do this, like the reason we have this before Sophomore's programming levels, is because a lot of these things we actually use them in the Sophomore programming levels, and these weren't taught in our freshman track Solidity level. So that's why we have like this conceptual topic before we move on to the programming levels for Sophomore, and people have questions about that, so let's cover them. So modifiers, then we'll do events, constructors, inheritance. We will do how to transfer ETH from a smart contract, and we will do calling external smart contracts, and we will do import statements, though we kind of already do this in freshman. And last but not least, we will cover Solidity libraries. So there's a lot of things. Cool. So we have a question. Is there a way to set breakpoints in VS Code or Hardhat the way we can do it on Remix? So if you debug your contracts in Hardhat, we haven't covered that yet. You can technically do it, but breakpoints on Solidity don't work the exact same way as you would expect them to in other languages, because they show you lower level data than usually you're used to. Alternatively, what you could do though, in Hardhat, you can do console logs. So if you're using Hardhat, you can log things on your terminal from inside your contract. If you're like, while you're testing your contract, I was kind of like showing it off here and there to a couple of people earlier in pair programming, but we'll probably cover that a little more in depth soon. But yeah, that's one way to debug if you're using Hardhat. And yeah, all right. So hello everyone. I see a couple of new faces. Thank you. Thank you for joining. Cool. So let's get started. Let's see. First thing we want to do, mappings. All right. So what are mappings? Actually, you know what? Instead of a single contract, let's just make a bunch of contracts. So we'll do first contract for mapping. So what is a mapping? A mapping is depending on what language you're coming from, if you have previous programming experience, they are the same thing as a dictionary if you're coming from Python, or an object if you're coming from JavaScript, or a hash map if you're coming from Java, or like just a unordered map if any of you guys here is coming from C++. It is the same thing, but if you're a sort of new programmer, you don't really know what this means. A map is essentially, so a map is a data structure where you have a key and you have a value, right? So a mapping goes from a certain key to a value, and the way this works is you can contrast this with arrays. So in arrays, you have a list of items, and so you have a list of items, and they're just there, right? Like you have a list of values. But what if you want to give names to those values, right? Like what if you want to represent a person, actually no, that's a bad example. But yeah, like what if you want to give names to those values, or what if you want those values to be based, we'll look at an example, but basically mappings are kind of similar to arrays where you can store a bunch of values in it, but at the same time, you can provide a key which you can use to get access to that value. Let's just look at a simple example. So let us say we want to create a mapping, we want to make a contract where every address can set a mood, right? So in the freshman track, we had a mood contract where there was a global variable, a string, and anybody could like update it, and they could like set a mood, and then somebody else could get a mood. But it was like a global thing. Like if you set a mood and I set a mood, I would overwrite your version. I would overwrite your mood. So let's say we want to extend that. Hi, I'm new to blockchain. Is this an advanced session or for beginners? So this is kind of intermediate. This is not completely beginner friendly. If you want to look at our beginner ones, like click on our channel or like go to our website, LearnWeb3 DAO, and our freshman track. The freshman track is targeted towards complete beginners. This is sort of the level after that. So if you're just starting out, you probably want to go do the freshman track first, and we'll have a recording of this available later for you to look at. Cool. So yeah, let's say we want to extend that mood contract, and instead of everybody writing to a single mood, we want that every address can set its own mood, and then we can fetch that, right? So earlier in the DApp contract, we just had a variable like string memory mood, and we were updating this. But now we want to make it so that every address can set its own mood and it doesn't overwrite the other person's one. So for this thing, we can use a mapping. So we map, so again, we have a key and a value. So the key in this case would be an address, and the value is a string, right? And we'll just name this, make this a public variable, and we'll name this moods. So what this means is this is a bunch of items. Moods has a bunch of items in it, and we can access someone's mood value doing something like moods and like an address here. So something like this, and this will result in a string that is the mood. So everybody can have their own mood. It's kind of like arrays where you have a bunch of values, but instead of them just being in the array, you can actually reference them by a key, and the key in this case is our address. Cool. So let's create some basic functions to see how it works. So let's create a function called getMood, but this time we will specify an address for whom we want to get the mood of. Like address, let's call it user, and we'll do public view returns string memory. Remind me to explain memory versus storage after this. So yeah, so we'll return a string from the getMood function, and all we need to do is we return moods of where the key is the user address. So it will return the string value that is associated for this address in this mapping. And if we want to set it, so we do set mood, and we take a mood from the user, and this is again a public function, and here we just do moods for message.sender is equal to mood, right? So I'm going to deploy this, and I'm going to show it to you what's happening here. So let's compile. All right, compiled. Deploy, and let's deploy on, what network am I on? Oh, I'm in Coven. Okay. So yeah, so let's deploy this mapping contract. Let's see what happens. All right, I'll hit confirm. So we'll wait for that to deploy, and there we go. All right, so okay, so my current address, if you look at it, I'm currently connected to this account, which has, so my current address is this. So if I set mood and I name it, like I say, like happy, right? And I set it, And sorry, my internet is just slow today. Cool. And while we wait for that to happen, while that transaction goes through, what I'm actually going to do is I'm going to go into MetaMask and I will switch to a different account. Do I have any Coven ETH on any other account? No, I don't. So let me just switch to this account, LearnWeb3 DAO. I actually need to send it some ETH on Coven so I can make transactions. I'm just going to send it like half an ETH. Or you can get it from like the faucet. I just have it in my wallet, so I'm just going to transfer it to the other account. But yeah, so what we did was we set a mood from my main address, which is this one, and now I'm going to set a mood from my other address, which is the LearnWeb3 DAO MetaMask address that I have. So I switch to this account, and here I do mood excited, and click transact. Confirm. And the address for the LearnWeb3 DAO crypto account is this thing. So LW3 address is this. So I set two different moods from two different addresses. And what I can actually do now, if I go to get mood, and let's say I put my main address in there in the user parameter, and I click call, it shows me happy. So it shows the mood that I originally set. So the second time I set a mood from a different address, it actually didn't overwrite it, because that mood was only set for that address's key. So that mood was only set for this address. And when I'm reading the mood for this address, it's not overwritten. It's still set to happy. But then if I copy paste this address, the LW3 address, into get mood, and I call it, it's going to say excited. So I hope that kind of makes sense. Are there any questions about what mappings are and how they kind of work? And let's actually also talk a little bit about use cases, right? Because I just showed you a very simple example, but maybe this doesn't explain to you like why are mappings actually used, like what is some real use case of mappings. So in Freshman, we developed a token, and we also developed an NFT. So for the token, we were using the ERC20 contract, the ERC20 standard, and we say that, oh, like the ERC20 standard, it's a token, and you have a balance, and you can like send money here and there. But how does that actually work? So all it is, it's really simple actually. So the way your balance is represented is the ERC20 token contract just has a mapping from your address to an integer called balances. So everyone has a balance of that token, and it's just stored as a number in this mapping. So like my address has a certain amount of balance. It could be 0, it could be 100, it could be 1,000. And when I'm sending tokens to somebody else, all that's really happening at the core is, like if I send 50 tokens to someone else, my value of like balances my address, the value goes down by 50, it decrements by 50, and the other person's value increments by 50. That's how transfers work if you're using tokens. So like mappings are a really common thing. There's a lot of use cases for them. But cool. I don't see any questions specifically about mappings, so I'm gonna move on. So somebody asked me to also explain memory versus storage. So I'm gonna do a quick explanation of memory versus storage. So let's create a contract memory and storage, and let's see what happens. So first thing you need to know, Solidity has 3 types of storage locations for variables. So 1 is memory, 2 is storage, and 3 is call data. But don't worry about this. Don't worry about call data right now. It is sort of rarely used, and you will not encounter it too much in the wild. So actually, I'm just going to get rid of it so I don't confuse you. But let's focus on memory and storage because they're used a lot. So what does a storage location mean? Think about a computer, like a physical computer, like your laptop or desktop. Where is information stored in a computer? All right, so the answer is there's multiple layers where information is stored. So the closest thing is like the CPU cache. That is your physical Intel or AMD CPU that has a cache directly like on the processor. And it's very small. You cannot store a lot of information on it. You can store like very tiny amounts of information on it. But it is the fastest storage possible in your computer. Like your processor can read and write values to the CPU cache like super fast, like millions of times a second. But you cannot store a lot of information there. So it's tiny, but extremely fast. All right. And then you have a couple more levels of caches. Like modern processors usually don't have a single cache. They have like L1, L2, L3 cache and whatever. But for simplicity, let's just say CPU cache is one layer. After that comes your RAM, so your random access memory. So random access memory is sort of, you can store a decent amount of information there, like 8 gigabytes, 16 gigabytes, 32 gigabytes on like personal computers. So decent amount of storage and decently fast. It's kind of a middle ground. So obviously it's slower than the CPU cache because the electricity has to flow from the processor across your motherboard to the RAM, do something in there, and then flow back to the CPU. So it takes longer to read and write to the RAM, but it has significantly more storage than the CPU. The third place is your hard disk or SSD. Much more storage and also much slower. So on hard disks and SSDs, you can store terabytes of information, right? Like insane amounts of information, but it is very slow to read and write from them as compared to RAM. So it's, you kind of go through these layers with different levels of trade-offs. So like you start off with small storage but super fast, all the way up to like huge storage but much slower, right? And computers use these different levels of storage for different things. In the CPU cache, you store information that is being used, info that is being used very frequently by your processor right now. That's the only way it makes sense because you can store a tiny amount of information there. So you want to make sure you're storing something that is really important and it's being read and written to a lot. The RAM is kind of like, we want to keep things moving decently fast. So like your web browser, the RAMs here, like all of this information that I see on my browser, this other tab I have open, like all of this is stored in RAM. So that is why, like, you know, that meme like, oh, like Chrome takes up so much RAM. If you open like 50 tabs of Chrome, your computer will crash. It's because like it's storing all of that information in your RAM, and your RAM has a certain amount of space. And hard disk or SSDs, these are mostly like long-term storage things. So you wouldn't use this like if you're reading, writing something really frequently, but like you would store your documents, you would store music, you would store movies, things like that, like long-term storage that you don't like read, write very often. But where am I going with all of this? This is a lot of unrelated stuff, it looks like, but not really. So Solidity kind of works the same way. Actually, this is the first question that you need to understand the answer to learn about what is memory and what is storage. the second question you need to understand is what kinds of variables are there? And I want someone to answer this. Actually, can someone tell me the difference between the data types of a uint and a string? Like, obviously they're different, right? Like, one stores numbers, the other stores strings, but what is sort of a lower level difference between these two things? How are these two different? Chetan, to answer your question, how does a protocol track all the tokens that have been minted? They don't. The short answer is they don't. Centralized exchanges have an application process to get your token listed on the exchange. Decentralized exchanges, they don't track mints. It's just like every token is just a smart contract at the end of the day, and all you need is a contract address to tell a decentralized exchange that, hey, this is a token. But yeah, they're not like actively tracking it. Okay, going back. So we have some answers. So you have an answer, uint is fixed and strings are arbitrary. Another word for this is dynamic. So what implications does this have? What implications does it have to have something be fixed versus dynamic? The implication it has is, if you know the size of a variable, like if you think about like a uint 256, right? It's 256 bits long. It's composed of 256 zeros and ones in binary. So regardless of the value, regardless of whether you're storing the number 0 or you're storing the number like a gajillion in there, it doesn't matter. The length of the variable will always be 256 bits. Strings, however, you don't know what their length will be at compile time. Because oftentimes, like even in this mood contract, right, the user sets the mood, and the user can set like whatever the fuck they want. They can set like a 1-letter mood, or they can set a 100-letter mood, and those two are very different. They require very different amounts of storage. One is 100 times longer than the other. So dynamic things have variable amount of storage requirements. You don't know how much storage they will actually need. Whereas things that are fixed, you can like know at compile time that this is a uint variable. It's never going to exceed 256 bits. It doesn't matter what the value is. So we have fixed variables and we have dynamic variables. All of this that I've just explained, it goes to say Solidity itself has two types of storage locations that we care about. So memory and storage. And there's kind of like the implicit understanding that some things you don't need to specify a storage location for. So if you look at this contract, when we wrote string here, we had to specify memory. And if I delete this, it will actually like complain. It will give me a syntax error. It won't compile. But for address, I didn't have to say that. And in fact, if I do type memory here, again, it's going to give me an error saying you don't need that. The difference between these two things is address is a fixed data type, and Ethereum address is always 42 characters long, whereas strings, as I said, can be anything, right? So fixed data types in Solidity, when they're running on the Ethereum virtual machine, you can run them, like you can place them on the stack. I'm not going to go too deep into like what is a stack. You can look it up. But a stack is like a location where you can store variables up to a fixed size. So since we already know how big an address variable is, regardless of the value, I can place its value in the stack. And the stack is like a fast way to read and write variables from. However, strings, because I don't know what their value is, I can't place it in the stack. I don't know how much space it will take up on the stack. So I need to place it in the heap, which is a separate location, and the heap is kind of analogous to the computer RAM that I was talking about. So think of the stack as the CPU cache, which is tiny, extremely fast, but you can only store a certain amount of data, and you want that data, you want to be able to predict how much storage on the cache you will use. Whereas on the RAM, you can store more information. And that's what we do when we're like using dynamic variables. So when you're using things like strings and you specify the word memory, it kind of goes on the heap, which is like the analogous thing for a RAM. And kind of makes sense, right? Like, what is the full form of a RAM? A RAM is like random access memory. So you specify the word memory to ensure, to tell Solidity, hey, this thing needs to go on the heap. I don't know how long it's going to be. And the third thing, the other type of storage, like which is storage, it is like the hard disk equivalent. It is like long-term things. And by default, anything that is declared as a global variable. So like if I do like UN256, my variable, and then address, some address. Actually, if I do a string here, string, some string, I will not need to write memory here. It does not complain that I didn't write memory here. Because anything that's stored as like a global variable in a contract, it is automatically put into storage. Because that is a long-term thing. This is not going away anywhere. This is here to stay, and it will always stay for the lifetime of this contract. Whereas things in memory, like this mood string, it will only exist for the execution of this function. And once the function is done, we don't need it anymore. We get rid of it. So it goes in the RAM, whereas these things go in the hard disk. That's an overly long explanation, but memory and storage are kind of tricky topics, and they do require like some lower level understanding. So hopefully that makes sense. Is this being recorded? Yes, this is being recorded. This will be on our YouTube. Is it the same stack and heap as JavaScript's runtime engine? Yes. I mean, conceptually, they're the same thing. Like, a stack is a type of data structure, and a heap is a type of data structure, but usually stacks are smaller, but faster to read and write from. That's why I compared them to the CPU cache, whereas heaps are usually larger, but relatively slower compared to stacks for reading and writing information. So I compared it to the RAM, and then global variables go into storage, long-term storage, which is why I compare them to like the hard disk of the Ethereum virtual machine. Okay. Let's move on. Memory and storage are always a long topic to explain. Let's take a look at our next thing, enums or enumerators. So let's make a contract enums. What is an enum? Actually, it might be good. I'm just going to show you the Google definition. So what is an enumerator? The enum is short for enumerator. This is not the computer science definition of the word. Let's look at the CS definition of the word. Oh, actually, Google has more definitions. Come on. No, this is not related to census or governments. This is, yeah. Let's look at enumerator for computer science. Okay, this is too low level, too theoretical. I'll just explain it in my words. So enums are enum is short for enumerable or enumerators. Essentially what they are is they are human readable types for a set of values. This is really vague. This is really vague. But think about this. So let's say you're like trying to like track work. Like you're using like some work tracking tool, or you're using like task management, and let's say you have like a workflow of how like a thing progresses, right? Like let's say you have like a to-do app or something. So when you create a new task in your application, let's say it has like a sort of like it has like the to-do status. So like we'll list down possible statuses of a task in a to-do application. So the first possible status is to-do. You haven't started this yet. The second possible status could be in progress. And a third possible status could be like done, right? A fourth possible status could be cancelled, right? So you have like these four statuses, and let's say you wanted to create a to-do app in Solidity for whatever reason, and let's say you hypothetically you had like let's say you had a mapping, and the mapping goes from like let's say like every to-do has an ID, so it has a uint ID, and you want to track the status. So one way you could do that, you can do that with a string. So it's like ID to status mapping, right? This is one way to do it. And what you could do is like you have a function called add task, and you give it an ID, and and it will just create a new task, add to the mapping for this ID, and it will set the default status, which is to do. It hasn't started yet. And then you could have a function which is like update status for a to do ID. And what this does is, and let's say you're also taking in like new status, and you set this to to-dos ID equals new status. And lastly, let's just make a function called like get status, which takes in an ID, and it returns a string, which is just to-dos ID. This is one way of solving the problem. It will work, but it's not the best way you can do this. The reason you can't do this is because, I mean, you can do this, but like the reason it's not good is because like strings are dynamic length. Strings, like, also like you don't know if the string you're being passed here is possibly one of these four. For all I want, I could just pass my name, and like you'd have to check if the string being passed is the same as one of your possible options every single time, and that's just useless increased complexity that you don't really need. All right, so let's look at an alternate solution. So we'll just make a note: strings are not the best way to represent status because dynamic length can be expensive on gas, and two, have to validate each string input to make sure it's a possible option. Oh, I realize it's being covered by my live stream, my video. Okay, so let's comment out this code and let's just say strings are not the best possible option. What is another solution? Alternate approach. We can use numbers to represent a status. So we have 4 statuses, and we actually kind of already assigned them numbers, so 1, 2, 3, 4. Just to make things easier for the computer, we'll start from 0. So we'll say, so we'll represent each status by a number, right? And this time we can just have a mapping from UN256 to UN256 for to-dos list, and this is a mapping from, again, ID to status. And we have similar functions. So we have function add task for a certain ID, and this will create a new task at that ID and just give it the default status of 0, which is the to-do status. Then you will have function update status for a certain ID, and then a new status public to-dos ID equals new status. And here, like, checking is a little bit easier because you can say, like, oh, like, I require that the new status must be a value less than 4 because all your statuses only go from 0 to 3. So you can ensure that it's not invalid input by adding this line here, and it's fine. And then we have a line of, like, get status, and this returns a UN256, and it just returns to-dos ID. All right, this is a solution much better than strings, much more gas efficient than strings, and it's fine, and it kind of works when you only have like 4 possible options. But imagine if you had way more. Imagine if you had like 50 options, right? And 50 options, and like programmer is coming in and he's like, oh, like what is the number 16? What does number 16 mean? And then they're gonna go look it up, and they're like, oh, what is 19? What is 21? What is 25? And it's a pain in the ass. It's a pain in the ass to, like, you have to have documentation somewhere that tells, oh, 0 is this, 1 is this, 2 is this, 3 is this. And it's kind of a pain in the ass going back and forth, oh, like, what is what? This is the exact problem that enums are here to solve. So what we could do, enums provide human readable names for a given set of constants. So like the status, we have 4 possible options for the status, and it is a set, and we only accept those inputs. There is no 5th option that you can possibly use. So that is what enums are used for. You can have a set of possible options, and enums help you give them human readable names, so you don't have to deal with weird numbers. So what I can actually do here, I can define an enum called status, and I can list down all my possible options here. So to do, in progress, done, and canceled. So I define an enum like this, and what I can do now, oh, I don't need the semicolon. Expected primary op. What did I mess up? Oh, this should be return. Can be restricted to view. That's fine. My bad. Okay, so I can define an enum like this, and then in the mapping, instead of mapping from an integer to an integer, I can just map from an integer to a status enum type. And then here in add task, instead of setting it to 0, I can set it to status.todo. And this is already like significantly more readable than understanding what the fuck was 0. Similarly here, instead of taking in a UN new status, I can just take in a status new status. I don't need this anymore, because if I'm taking in a status type, it can only be one of these 4 values. And then I just set it to new status, so I'm guaranteed that it's one of these 4. And then I can return it just as status. So it's a lot more easier to read. in fact, you could like probably break this update status function down into a few more to have a further look at its readability. So maybe we have a function called like mark task in progress, and you just give it an ID, and this will just do todo's ID equals status dot in progress. Much better than typing todo's ID equals like 1, and like so on and so forth. So let's actually deploy this and see how it works, because there is one other thing that I want to explain to you about enums. So let's get rid of that old contract, and I'll switch to my enums contract, and let's deploy this. Confirm, and I'm going to take a look at chat. I don't think you need ID with enum over there. Well, I do need ID. Like the ID is for the tasks. You have multiple tasks in your to-do application, and each task has an ID, and each task has a certain status. So the ID has nothing to do with the status. The ID is to identify which task you're talking about, and then for that task, it has a certain status. All right. So let's look at how this would work. So let's see, we open up our contract, we deployed it. So I'm just going to add a new task at ID number 0, and it will set it by default to status.todo. And here's where things get a little bit interesting. So actually, before I go into that, can someone tell me what they think? How are these enums represented internally? Like when Solidity compiles this, how does it store these values? Like a little bit of a vague question, but like I don't know how to ask it any other way. Like, how do you think Solidity actually stores these values after compilation? The 4 possible options that we have. All right, I'm just going to move on. So one way to do it, again, would be strings. So perhaps Solidity, when it compiles, it converts this into a string, and it stores them like this internally, but that's not great. We already looked at the string solution, and that's not great. Integers were a better solution, but the problem with integers was it wasn't human readable. But now we do have a human readable representation. It doesn't matter if Solidity actually stores them as integers behind the scenes. You don't care about what's happening behind the scenes. You care about, as a programmer, does it look readable and is it easy to work with? So in actuality, we will see. So I just added that task and the transaction went through. If I get status of task ID 0, what do you think I'm going to see? Do you think I'm going to see to do? No. I'm actually going to see 0. And the reason I see 0 is because internally, Solidity represents enums as numbers, and they are numbers that start at 0 and go up by 1 for however many items you have here. So like this is 0, 1, 2, and 3, and then if I add more things, it would be like 4, 5, 6, and so on. So internally, they're still being represented as numbers. Internally, it is the exact same thing as when we implemented it directly with numbers. But this approach is much more readable. It's easier to work with, it's easier to read about, and it's harder to make mistakes when you're using enums. It's much easier to make mistakes if you're using numbers directly. Like if you have a list of 50 possible options and you type 18 instead of 19 somewhere, things could go haywire. And enums are much more readable and much easier to work with for that reason. But behind the scenes, they're still being stored as numbers. So when I mark a task in progress, let's say I call this function. So I want to mark task ID 0 in progress. Do the transaction. So once that goes through, so in progress is this, and once the transaction goes through, it's pending. All right, there you go. So once the transaction goes through, if I try to get the status of it again, it just says 1. It doesn't say in progress, it just says 1, because in progress is 1. So that's enums. Enums, again, recapping, they provide a human readable way to represent a set of possible options for something you want to use. So you use them to restrict a variable to a set of possible options while maintaining readability. And you don't have to do this in a mapping, right? Like you could have a variable called status. This is a global variable which can only have one of these 4 possible values at any given time. And if you try to set it to something other than these 4, it will give you an error. So that's enums. So like enums are a way to restrict a variable's value to a predefined set of possible options while maintaining human readability and ease of use. So that's enums. So yeah, the uint is stored on the stack. They're not stored in storage because it is not like, I mean here, yes, these things are stored in storage. Yes, any global variable here, this entire mapping is stored in storage because it is global to the contract. But if you're talking about like, if I were to pass a status here, this would go on this stack. This would not go into storage. Sorry, I misinterpreted Sneha's answer there. She's right. Like this thing does go in storage. This entire mapping goes in storage because it's a long-term variable. So how do you store a string to do? Oh, I didn't cover that, but like, I mean, you can, you could like, for example, like I'm not teaching you how to build a to-do app. I'm just teaching you enums, but like you could have a second mapping which goes from uint to string, which is like to-do descriptions. And when you add a task, you could ask the user to provide a description for the task. And in the same ID, you could set it to like that description or whatever. But again, like I'm not trying to build a full-fledged to-do app here. I was just trying to explain what enums are. So don't worry about this. Obviously, in a real to-do app, you would likely have more features than just tracking the status of random IDs. Cool. Okay. Okay. Any questions about enums before we move on? I mean, you could also store the string as part of a struct. I think the next thing on our list is structs. So actually, I can just continue this to-do app example when we go into structs, and you will see a better way than to store 2 separate mappings, actually. 2 separate mappings are not the best way to actually do that, but I haven't taught structs yet. Cool. If there's no other questions, let's actually move on to structs. So let's create a new contract. We will call it structs. Now, what are structs? This will sound very familiar to you. Oops. If you're coming from C++ background, structs are exactly what they are in C or C++. If you're coming from like, if you're coming from I think Python or Kotlin background, structs are the same thing as data classes. If you're coming from a JavaScript or Java or pretty much any other OOP language background which don't have structs explicitly, structs are kind of like classes, but without any methods defined on them. So essentially, a struct is a way to it's a way to hold a bunch of related information together, but you don't define methods on them. That's how they differentiate from classes. Like classes in JavaScript or Java or whatever, they have some data and they have some methods. Structs are just the data part of it. If you don't have any methods in a class, you just store some data, and you just have them to like stay close to each other because it's related information. That's a struct. It's a data structure, literally. So continuing with the to-do example, so he asked a good question, like where is the to-do description actually stored, right? Like, yes, you can have two mappings, like I did. So what does a to-do app need? So ideally, you have a description of the task, you have a status of the task, then there's a unique ID for each task, and then you could have like I don't know what else goes into a to-do app. I don't know, maybe a title that is different from the description. Cool. So one way to do this would be kind of just do a bunch of mappings, right? Have a mapping that goes from UN256 to a status. I will just copy over the enum from here. So you could have a mapping that goes from ID to status, so there's to-do statuses, and then you could have a mapping that goes from ID to string, and this is like to-do titles, and another mapping from UN256 to another string, and this is like to-do descriptions. And yeah, so one way to hold all of this information for a given task, so this is like ID to whatever, all these mappings go from ID to whatever, and then when you do add task, you can give it an ID, you can give it a title, and you can give it a description. And then you can add things in all of these different mappings, and you can do like, oh, the status for this ID is status.todo, and the title for this ID is title, and the description for this ID is description. This is one way to do it. It is enums are just a way of tracking ifs. Well, it's not ifs. It's a way to store it's a way to restrict a variable to a set of possible options. So like, I don't know, like when you message someone on WhatsApp, it has a certain status, right? Either it's sent, or it's delivered, or it has been read. So there's three possible options, and they show you the check mark on the WhatsApp app based on what the status of that message is. So they store that information in their database somewhere. And let me guarantee they're not storing it as a string. They're storing it as a number, because strings are not good for comparison. Strings are slow. Strings are expensive to do computations on. So they're storing it as a number, but there's only three possible options. So they likely actually represent it as an enum, because having the numbers 0, 1, and 2 doesn't make as much sense as message.sent, message.delivered, and message.read. It's solely a readability thing. You only do it to make things human readable, so you make less mistakes. Because when dealing with numbers directly, you can make mistakes very easily. That's what enums are. Code with Faith asked me, are structs the same as structs in Go or C? Yes. Go has structs? Oh, right, they do. But Go structs are a little bit different because in Go, structs can have methods defined on them, whereas in Solidity, they can't. In C, structs cannot have methods defined on them. For that, I think you need a class. Or maybe I'm remembering wrong. Maybe they do. I don't know. It's been a long time I worked with C. But yeah, they're pretty much the same thing, but no methods, just the data. Anyway, so going back to the to-do app. So this is one way you could store all of this information related to a task in your to-do app, but this is a pain in the ass. You have to maintain 3 different mappings, make sure every time you add something or update something or delete something, you're making changes in all 3 of the mappings, and it's just not great. It's not great. So what you can do, I'm going to comment this out, and what we can actually do is we can define a struct named task, and a struct can have a bunch of variables in it. So this struct, we want these things. So we will say we want a title, we want a description, and we want a status. So each task has these 3 things as part of it. And then what we can do is just we can have a single mapping. So you can just have a single mapping that goes from ID to task. And this is all of your to-do tasks. This goes from ID to task. And now, if you have this function, obviously the user needs to give you all the information. But instead of storing it in 3 different places, you can... Oh, actually, there's a bunch of different ways to initialize a struct. There's actually 3 ways to initialize a struct variable. So I'm going to show you all of them. So method 1. So the first thing you can do is you can push, you can set the value in this mapping directly. So you can be like tasks at ID is equal to a task type. So you write the name of the struct followed by parentheses, and in it, in order, you give it all the variables it needs. So title, description, and by default, status.todo. So this is one way you can initialize a struct. The other way you can initialize a struct is explicitly, so this thing works if you specify variables in order, but if you by mistake like put description here and you put title here, it's still going to compile because they're both strings, but you kind of messed it up. So if you want to be a little more careful and you don't want to rely on ordering of things, you can be a little more explicit with this, and you can say tasks ID is a task, so followed by parenthesis, and then you open curly braces, and inside the curly braces you write the key, so title, and this will be equal to title. So this here is the name of the variable in the struct, and this here is the variable we are being passed in the function, so key and value. And then do description, and then you do status, and this is status.todo. So this is the second way of doing this. Oh, I'm getting an error. I don't need a comma here, and I need a semicolon here. Okay, so this is method number 2 of initializing a struct. The third way to initialize a struct is to define an empty struct and then set each of its values individually. So you can just do like task and a random task, and then directly you can do like task.title equals title, and task.description equals description, and task.status equals status.todo, and then you can push it into the mapping. So task set ID equals task. So these are 3 ways to do the exact same thing. Personally, my favorite is this one. It's explicit, it's short. I kind of hate having to do this, and I don't do this because it's easy to make mistakes. Method number 2 is my favorite. So I am just gonna comment out the other 2 things for now, and we'll just take into consideration method number 2. So again, what is a task? What is a struct? It's a way to group together variables which are tightly related to each other, and it doesn't make sense to maintain their values individually, and you'd rather have them all together. And then now, if you wanted to like delete task, you wanted to have a function called the delete task, given an ID. Imagine what you would have to do earlier. If you had all 3 of these things, you would have had to delete from all 3 of them. But now you have a single mapping that just goes to a struct. So literally all you need to do is delete task set ID. And that's it. So this way you get rid of the entire struct. You don't need this task anymore. You get rid of it. If you had all 3 of these, you would have had to do it in all 3 of them. So you would have had to do delete, to do statuses, ID, and then delete, to do titles and ID, and same for to do descriptions, ID, but this is just annoying. So you do this. Another reason you want to use structs, other than heavily correlating information that's related to each other, is this is better for gas. I don't know how many of you guys have read the gas tutorial. The Ethereum virtual machine tutorial in Sophomore. But basically, when you group things as a struct, the Solidity compiler understands that these variables make sense to be placed together. So when code is running in the Ethereum virtual machine, it kind of pushes all these variables as close to each other as possible, and that in the smallest amount of space that is possible. So it is slightly better for gas than having to store them all individually, where the Solidity compiler doesn't know whether it's related information or not. So that's it for structs. And you can like add more things here. You can add like, I don't know, whatever you want. And then all you have to do is just add it properly. And you can also do like edit task. So the way you can edit something is like, let's say you want to edit task title. So given an ID and you have a string for new title, you can just do something like tasks ID dot title equals new title. Yep. And this will compile just fine. So the ID of task is stored to a UInt. Yeah, so it's a mapping, right? So as I said earlier, so mappings are like dictionaries or hash maps or whatever. So think of them like arrays, but instead of accessing things by the index of the array, you access things based on a key. So in this example, the key was an address. So you would do like moods and an address, and it would give you a string. In our case here, we have a mapping from uint to task. So the uint here would be the ID, the unique ID of a task, and then it maps to a struct where you have all the other information related to the task. Yeah. All right. Cool. Okay. All right. Well, we're already like 1.5 hours in, and we haven't made as much progress as I was hoping to. So maybe we have to break this into 2 tutorials, because I don't want you guys to be sitting here for like 5 hours. That does not make sense. What happens if the ID provided does not exist in the mapping? So if it does not exist in the mapping, anything that does not exist, Solidity has default values for everything. So like if you give it an ID that doesn't exist, it will go to the task. Actually, let's start with a simpler example. So in this mapping, if you give it an address that hasn't yet set a mood, it will just return you the empty string, because like just an empty string, because that's the default value for string data types in Solidity. If this were a Boolean, it would return you false. If this were a number, it would return you 0, because those are the default values for data types in Solidity. Now in this case, we have a struct called task. Task itself is automatically provided a default value, and the default value for a non-existent task is basically a struct which has the default values of all of this. So like if I were to do like some random integer ID that doesn't exist, the task I would get back would have a title, which is the empty string. It would have a description, which would be an empty string, and it would have a status, which would be the first thing in the status. It would be set to do. That would be the default value of an enumerator. But yeah, it would just return you default values, which would be empty, empty, false, 0, first thing in the enum, or whatever. Just the default value for all the variables that are present in the struct. It doesn't raise exceptions. It doesn't raise errors, because you're just like sort of reading from the chain, and it will just say like, oh, it's like an empty string. It hasn't been set yet. It has no value. Yeah. So actually, this raises an interesting question. Assuming you were building an app where empty strings were possible values, and if you gave a random ID and it gave you like empty strings and a status of to do and whatever, how would you differentiate it from a real task? So a common way to solve this would be to just have a Boolean, just have a bool here, which is like set, is the value set or not, and when you add a task, you set the value to true, and then based on this Boolean, you can check whether it's something that actually existed or is it just a default value, because the default value for a Boolean will always be false. But if you're creating a real thing, maybe you can set it to true, and if it's returning true for this variable, then regardless of what the values are for these 3, you know that it's a real thing, even if it's empty strings or whatever. So somebody actually just gave it an empty string. That's a common way to sort of solve for that, to be able to differentiate between default values and real values in structs. Okay. I don't know how much of this we want to cover. Let's go for like another like 20-30 minutes, see how much we can cover. And then we'll probably have to follow up on this with a second video, because this is going to be really long otherwise. So let's cover view and pure functions. All right, so I'm gonna make a new contract, view and pure functions. So what is the term for this? So Solidity has like 3 kinds of function visibilities. Function three kinds of function visibilities. Actually, visibilities is not the right word because it gets confusing with like public, private, internal, external versus like view and pure. Three kind of function. What's the word for this? I mean, technically it is used to describe if the function has any side effects or not. Three kinds of keywords to indicate side effects of a function. So what is a side effect? A side effect in computer science means something that changes the value of a variable beyond its own scope. So just to give you an example, so like if I had like some function here, and I had a variable here called x, and like I update it to like 5, but then I have a variable at the top called y, and I update the value of y. So this is not a side effect because x only exists within the scope of this function, but this is a side effect because it is changing the value of something that will reflect beyond the function itself. It's a side effect because it's changing the value of y, and this value might be used in a second function somewhere else. So this is considered a side effect of the function that is changing a value beyond its own scope. So that's what a side effect is. And in Solidity, you can have three kinds of keywords which indicate what kind of side effects a function has. So by default, the first kind is no keyword at all. So basically like kind of like this function. We didn't specify anything. We just said it's a public function. This is visibility, but we didn't say anything about side effects here. The second kind is a view function, and the third kind is a pure function. So functions, so let's first define view and pure, and then we will get back to the first one. So a view function is a function that reads from state. So it reads the value of variables in the contract, but does not write to state. All right. So an example would be like function get y, and all it does is it's a view function which returns a uint, and all it does is it returns y. So if I try to compile this code, it compiles just fine. And what is this doing? So the view function, it's reading the value of this variable. So it's reading from state, but it's not modifying it. It's not updating the value of y. And you will see if I actually get rid of the view keyword from here and I try to compile it, the compiler will give me a warning. It's not an error, it's just a warning that, hey, actually, you can restrict this function to be view only. And the reason you want to do that is because the compiler, when it's compiling your code, it can then pre-optimize for it, and it can optimize for the fact that this function never changes state, so it can make it a little more gas efficient. So the compiler is smart, and it will tell you, hey, like this function is not changing state. You can just say it's a view function. So that's what a view function is. It reads from state, but it does not write to state. All right. A pure function is a function that does not read or write to state. So it doesn't do anything. It doesn't touch the state at all. It doesn't read from it. It doesn't write to it. It's its own thing. So an example is like add two numbers, and you give it a uint x, and you give it a uint y, and it returns a uint, and it's just returned like x plus y. actually, let's not call this y so people don't get confused. Let's call this a and b. So it just returns a plus b. So this thing, if I try to compile this, again, the Solidity compiler is smart. It's like, oh, this function is not reading or writing to state. You can actually make it a pure function. And again, you want to do this for gas optimizations. And you can type pure here and compile it, and it goes away. So a pure function is something that doesn't read or write to state. It doesn't touch the state at all. And then there's functions like this, which like it can possibly read from state, but also it can actually write to state. So it's changing the value. It's modifying the value of this state variable here. And this is the first kind of function where you don't give it any keyword at all. And in fact, if I do try to say view and I compile it, it's going to say error. It's not going to let me do that. And similarly, if I just try pure, it's going to say error. It's not going to let me do that. Another handy way to think about it, view functions are free. It doesn't cost you gas to call view functions. And let me actually show it to you. So let me deploy this and get rid of this. I'm going to select view and pure functions and deploy this. All right. All right, so we have our contract deployed. So we see, so if you notice in Remix, the functions that come up in the orange color are functions that will cost you gas, and the ones that show up as blue are the ones which don't cost you gas. They're free. So like if I click get Y, it doesn't pop up MetaMask. It doesn't ask me to like pay gas for calling this function. It's free. And it just gives me 0 because that's the default value for Y. And then if I call some function, which would update the value to 5, I'm writing to state. So I need to pay gas for it to change the state on the blockchain. And I pay a transaction fees. I hit confirm. And we'll wait for it to go through. All right. And now if I get Y, it returns me 5. Again, it didn't cost me any gas. It was free. So view functions are free. They don't cost you any gas. You don't have to do transactions. It's just like reading. Whereas this function costs me gas. Pure functions also don't cost you any gas because you're not doing anything from the state. So I can just give it like add two numbers, 5 and 5, and it'll just give me 10. It doesn't like open up MetaMask or anything. So view and pure functions are free to call. They don't cost gas. Other functions which modify or write to state cost gas. So that's view and pure functions. It's a simple topic. And again, you only want to do this for gas optimizations. Because it will, like obviously like these functions themselves don't cost gas, but when you're deploying the contract, it costs you a certain amount of gas to deploy a contract. And if I didn't specify them as view or pure, it would cost me more gas to deploy the contract than it would if I did specify them as view and pure. So that's where the gas optimization happens, because calling them is free. There's no gas there anyway. Cool. So that is view and pure functions. Let's see. Let's take a look at modifiers. So modifiers are interesting. Create a new contract, call it modifiers. So modifiers are Modifiers are pieces of code that can be run before or after any other function call. And we will get into like some examples of this once I show to you how it works. So imagine imagine you're writing some type of contract where the owner of the contract, the admin, the administrator, has access to certain functions, but other people do not. You don't want anyone to have the ability to call those functions, but you want that the owner can call those functions if necessary. So perhaps like it's like, oh, you're launching a new token and the owner is the only one who can mint it. So the owner decides who gets the token. So they have a function where they can mint the token to anyone's address, but other people cannot just call the function and get free tokens whenever they want. So you could imagine like things like that. Let's try to code that out, not the token part of it, but just the access restriction part of it. So let's say you have a variable called owner, and in your contract constructor, what you do is you set owner equals message.sender. So whoever deploys the contract becomes the owner of the contract, right? And then you have like a bunch of functions. So you have function somefunc1, and then you have somefunc2, and you have a bunch of these, right? You have like 10 of these. Let's just say we have 4 of these, so it can all fit on a single screen. So you have 4 functions, and you want that all 4 of these can only be called by the owner, and then maybe there's like 5 more functions that can be called by anyone you want, but these 4 should only be able to be called by the owner. So how do you do that? You can do that like kind of easily. So basically you could do it with require statements, right? So in every function you can have a require that the message.sender here must be equal to the owner address, otherwise unauthorized. You're not allowed to call this function. So only if the person calling this function is the owner, then we run rest of the code. Otherwise it throws an error. And now you can like copy paste this everywhere. You can say, oh, like this is here and this is here. This is unnecessary code duplication. And again, it has an impact on gas. It has an impact on how much it will cost you to deploy your contract to the network. Because technically you have 4 lines of code doing the exact same thing, but the compiler doesn't really know that. So it's like it's additional code that you're compiling and deploying to the network that you could have done in a better way. So instead, what you can do, you can create a modifier. And you can create a modifier such that I said that modifiers are pieces of code that can be run before or after a function call. So essentially, in all of these functions, before the actual function runs, we just want to do this check. That's all we want. So how we do this is we create a modifier like this, and the modifier keyword, and you give it a name. So let's call it only owner. And you define the modifier like that, and you do this line, you take this line and you put it here. So modifier has access to the same global variables that any function has. And then there is a special keyword that you can only write if you're writing a modifier, which is underscore. So it's literally just an underscore and a semicolon. And underscore semicolon tells means run the rest of the code here. So in this specific example, in this modifier, we first have a require statement, and then we say run the rest of the code here. That's kind of what we want. So we want to run the rest of the code after we have a certain check. So I can get rid of all of these lines, and I can just apply this modifier to each of the functions by like typing the name of the modifier. So I can do like public only owner, and I can do this everywhere. So I do it like this, and then all of these functions, before they run, they will run the modifier. So they will do this line, and then the underscore will tell them, okay, go run the rest of the code now. So this is an example of the modifier running before the function call. How you make it run after the function call is you just sort of take this underscore and you put it at the start. And this will say, oh, run the rest of the code first and then do this check. So functionally, in this specific example, it doesn't matter. It will behave the same way. But that's like in this case, the modifier is running after the function call, whereas if it's here, the modifier is running before the function call. And technically, you can also make it run in middle of a function call, right? Like maybe you have like two require statements. So like you have like some require statement. And then you could do something like this. So run the first statement, run the rest of the code, and then run the second statement. You can do this. So modifiers are usually used for things like restricting access to functions like only owner. They're used for things like validating the input of certain parameters. So yeah, like checking if an ID actually exists, or somebody is part of a whitelist, or something is present in an array, whatever. And then it can be used to prevent certain types of attacks. We will learn more about this in senior when we learn about how you hack smart contracts. But smart contract hacking, there's a really common hack called a reentrancy attack, and modifiers can be used to prevent reentrancy attacks. So yeah, essentially just pieces of code that run before, after, or like even in the middle of a function, and that way you don't have to have code duplication. You don't have to have 4 require statements. You can just have this one here and just say only owner, only owner, only owner, only owner. And then if you remove this, that means anyone can call this. And obviously, like, you can do more cool things. Like, it doesn't need to be a single line. You can have however many lines you want. You can do, like, you can write all Solidity code is valid here. It's not restricted. Like, a modifier doesn't have to be a single line of code. It can be like a whole block of code, and then you run the rest of your function. So it's very useful if you have a lot of code repetition, and you can just apply a single modifier everywhere instead of copy pasting code at 50 different places. Is it kind of like a decorator in Python? I'm not the best person to answer that. I actually don't know. I don't do a lot of Python. I'm not very familiar with the language, so I don't know. I've heard that it has decorators. I don't know what decorators do, how they work. So maybe not. I don't know. But yeah, does this make sense? Do modifiers make sense? All right. Let me check chat. Can a function have more than one modifiers? Yes. A function can have as many modifiers as you want. So that's actually a really good question. Is there an example I can show you? Let me see if I can find a example of multiple modifiers being used. Just a sec. So not this. Oh, our DAO contract. So sophomore level DAO tutorial actually uses multiple modifiers. So if I go to the sophomore track to the DAO level, if we look at the smart contract here, all right, so let me look at the final smart contract. I have a GitHub link somewhere. Right, .com LearnWeb3 DAO. Building a DAO. Oh God, DAO. Building a DAO. There we go. So the final smart contract for the DAO tutorial, if we take a look at it, it is, we actually have two modifiers there. So in the, we have three, right? So we have three modifiers. You don't need to understand what they're doing right now, but let's just say you have three modifiers, 1, 2, and 3, and certain. Wow, I can't believe that just actually happened. My headphones literally just, the wire got disconnected and fell. Can you guys hear me? Can you confirm if you guys can still hear me? I think you should be. Connecting to React, go through the Sophomore track. Go through our programming levels on the Sophomore track. The videos of that will likely come in the following weeks. But the Sophomore track has levels where we connect to Next.js, it's like React. We connect smart contracts to React, and then like we build like entire websites, entire dApps. So not just the Solidity part of it. So go through those levels. They are on LearnWeb3.io, and the videos for those will be coming soon. This is the first video for the Sophomore track. Cool. Yeah, as I was saying, so we have three modifiers in the DAO level, and some of the functions, if we see, like this one. So this function vote on proposal, it has two modifier calls. And actually there's something interesting here. These two modifiers we have here, they can actually take arguments. So in this example I showed you, we're not passing in any arguments, but if you see, like, a modifier is defined very much like a function, right? It's like, instead of the function word, you use the word modifier, and then you have a name, and then you do parentheses. So you can actually take in arguments. Like here, we take in a uint in the modifier, and then you can have a require statement or whatever you want that does something with that uint. But anyway, so if you look at this function, vote on proposal, it has two modifiers applied to it. The first one, NFT holder only, which is this modifier right here. And the second one is active proposal only, which takes in a uint as an argument. And it is this modifier here. And they're executed in order. So keep that in mind. If you have multiple modifiers, they will be run in the order they are specified. So if I change, if I mention this one before this one, then this will run first and this will run second. But currently, NFT holder one runs first and this one runs second. But yes, you can have as many modifiers on a function as you want. I'm sorry about the noise, dude. I don't know how they just fell off. But yeah, that's modifiers for you. Cool. Events, constructors, inheritance. Maybe we don't follow this order. Maybe let's do constructors before we do events, because I mean constructors we've kind of done them. I mean, I wrote a short constructor here technically, and we did constructors in our freshman track. So it's really simple. A constructor is an optional function that you can define, and it is a function that only runs once, and that is when the contract is deployed. So when you first deploy a contract, it executes the code present in the constructor, and then that's it. You cannot call it ever again. You cannot like manually call it. You can't do anything with it. It is just code that runs the first time the contract is deployed. So it is useful specifically in like cases like this, where you want to set a variable, like we want to set the owner address to be the address of the person who deployed the contract, right? Like you could hard code it. I can make this like owner equals like, I mean, I don't even need a constructor then, but I could just do like address owner equals this, and I can get rid of this. But then if somebody else wants to use my smart contract and deploy it themselves or do whatever they want with it, it's just better to sort of have it like this, because you can't specify message.sender here. This is not a thing, because message.sender is a variable that's only present inside a function, because it refers to the person who called that function. So the constructor gets called as part of deployment. So here message.sender is the address of the person who deployed the contract. That's really all there is to know for constructor. And constructors can take arguments. I think we did it in the freshman tutorials, but like you can take however many arguments you want. So like arg1 and then maybe a string, arg2, and whatever. And like if I try to deploy this, because like normally when you call functions, like when I was calling the function here in this view and pure contract, it would ask me to give it arguments as part of the function call. But when I'm deploying a contract with a constructor in it that takes arguments, I need to provide these arguments as part of deployment, which I modified the modifiers thing. So here I actually need to provide these arguments as part of the deployment, because this code will run as part of the deployment. So yeah, that's constructors. They're not a big topic. Cool. All right. I don't think it makes sense to cover events right now. Events is a long topic. Actually, I think we should leave this stuff for the next video. We did like 7 things if we count memory versus storage as a topic. And we have like 1, 2, 3, 4, 5, 6 more things left to do. We're already almost 2 hours into the video, so probably good to cut off and pick these up again in a later video. I'm gonna stick around for like another like 5-7 minutes or so, just to do like question and answers if somebody has any doubts, and then these other topics we can cover in the next video. But hopefully everything I explained so far made sense, and if you guys have any questions, like put them in the chat. Now you know how to add constructor value in Remix. Yes, you have to specify them as part of deployment, because constructor runs during deployment. All right. Yeah, some Q&A. If you guys have anything, I'm gonna play some light music in the background to change the mood a little bit. I'm sure people are tired listening to me rant about Solidity for 2 hours. Play some light music. My mouth is so dry, dude. I need some water. Oh god. Water can feel so good sometimes. No, this is too loud. If possible, add timestamps to the video. Okay. You guys are pressuring me. I will do that. Yeah, I will do that. Can we have the second session within a couple of days? Perhaps, possibly. Usually we take a vote on when we want to do sessions, but I guess since this is a continuation, I don't expect any new people to join. The people who are going to join are likely going to be the same people who are here right now. So maybe we can do it on Sunday. I'm not available tomorrow night, but maybe we can do it on Sunday. Sunday, same time. That would be Monday morning for all you guys in India. But Sunday, 10 p.m. Eastern time. Perhaps we could do it then. Yeah. All right. Sunday is great. Okay. Sounds good. All right. Gonna sit here. If you have any more questions, a couple more minutes. I'm just gonna play some Dino game. Oh god, the number of ads here is insane. Why are there so many ads? Oh, wants me to install something. No way. Isn't there like a game in Edge? Nope. Right. You guys have any other questions? JavaScript sessions need to be postponed again. Oh man, shit. Okay, right. So maybe not Sunday night. Does Sunday morning work? So that would be Sunday night in India. So that way it doesn't clash with the JavaScript sessions. So we could do Sunday morning Eastern, which would be Sunday night Indian time. Perhaps that works. Oh no. I'm gonna die. Look at me, I'm a streamer. Okay, whatever, let's look at chat. From Counter-Strike to this, yeah, I can't play Counter-Strike on this tiny little MacBook. Time, yeah, okay. Sunday morning works well. Okay, Sunday morning, we will take on these topics. Recording this for this video will go on YouTube. I will try to add timestamps as soon as possible, and it's going to be a pain in the ass to do that, but I think it would be helpful for anyone watching the recording later. All right. Okay. Sounds good. Cheers, guys. I am gonna head off. Thanks everyone for joining. Appreciate it as usual. Thank you so much. Um, Hope you have a good day slash night, and I will see you around the Discord. Bye bye. I'm gonna run this session now. See ya. Ping me on Discord if you have any other questions.